Hey guys, welcome to the video today. And this one's going to be not too long. It'll be just an introduction to what we're going to be doing in class tomorrow. Tomorrow you will see these guys, all these different shapes up here. You will actually have these tiles in your hands and you'll be manipulating them, moving around, using them to try to find out how to simplify variable expressions and add together what are called like terms. So your homework tonight is kind of just watch what's going on and see if you can come up with two or more rules for combining shapes. What are the rules? What kinds of shapes are we going to be able to combine or add together? What's going to cancel out? Try to come up with two or more rules for how these shapes work, or how we combine shapes. All right, so before we start, let's kind of introduce this to everything that we have up here. Basically, we have, if you look here, we have the x squared tile. Okay, it's blue and it's positive. We have x squared here. Here we have the x tile, and here we have the 1 tile. These are going to be like our integer chips, these two right here. These are our integer chips from before. Okay, and they're almost actually the same color. We had yellow and red before. So now we have our regular numbers. Here we have our x variables, and then here we have our x squared variables. And it's really no shock that the x squared tile is actually a square. That's where that squared thing comes from. Okay, so we're going to look at how this all works today. And this might seem a little strange about why are we doing it this way, but I think it'll help us once we get to the rules that we'll learn in a couple days. So our motivation and our purpose for today is how do we combine like terms. You'll hear me say that quite a bit, especially in the next couple weeks and months. But I usually kind of sometimes abbreviate that as CLT, combining like terms. And this idea of like terms is something that we're going to come up with today based on shapes. So this says, how do we represent the sum of the shapes below? So looking above, the red, or the blue, the green, and the tan or white are positive, and then obviously the red tiles are the negative quantities. So here, in this box down here, we have all positives. If you could think about, well, how are we going to combine these? You know, would we want to say we combine these two together, and then we have an extra? The way we're going to do it is actually combine the same shapes and colors. So if we look up here, we have two of these green tiles, and we have two tan tiles, or I'm sorry, three, if I can count right. 3 tan tiles. If we kind of look at our key above, 2 green tiles means that's 2x tiles. So we're going to represent this today as 2x. And then 3 tan tiles are our positive 1s. So we have 1, 2, 3. That's going to be just represented by 3. So this whole thing is 2x plus 3. Once again, this was x, and then 3. That's what we have there. And a lot of people are going to want to say, well, 2 plus 3, isn't that 5? Well, it depends on what we're talking about. We can't add together a long tile and a small square because they're not the same shape. We have to have it separated. There's only 2 of the greens and 3 of the tan squares. So we can't say that we have 5 of something because they're both different things. Our only answer we can do is 2x plus 3. We can't combine those any further. So it's not 5, it's just 2x plus 3. Using that same logic, what do you think the sum of this box down here would be? And what we'll want to do as you're thinking about this is we're going to want to group together the shapes that we have. So if we look our key above, we know we have all positive tiles. This is our x squared guy right here. This is our x squared. This is our x and our x. And then we have positive 1s. 1, 2, 3, and 4. So if we combine all this together, we have 2 x squared tiles. That's 2 x squareds. We have 2 green tiles, and those are x's. So we have 2 x's. And we have 4 regular integer tiles. And that's all we can do. We have three separate shapes, so we're going to have what are called three different terms in our answer. Before in math, you always get an answer like, x equals 3, or we get numbers and single numbers as our answer. In this unit and in this, kind of from now on, you're not going to have single numbers as your answers. And that's, some people do not like that. They're not used to that. But a lot of your answers are going to be expressions and things that can't be simplified much farther than this. And this doesn't look like a great answer maybe, but it actually is our correct answer. Okay. Go ahead and try this one too on your own. What would be the expression to represent what we have in this box? We're going to combine our like shapes here. This one's kind of weird because we have different colors this time. So we have obviously 3 rectangles and 4 squares. So you might think, well, we have 3 x's and 4 regular ones. But here we have positives and negatives. And we have to go back and remember how those canceled out before. So before we had integer tiles, and you should recognize this as something we know from before, from earlier this year. This is called something that you should know, and it's called a zero pair. So those actually cancel out. Do you see another zero pair? The next zero pair is right here. We have a positive and a negative x. They're different colors now, but the green represents positive. One positive cancels with one negative. That's a zero pair. It's gone. So what we have left is these guys right here. We have a green x, that's a positive x, so we can put a 1 in front of it. And then we have 2 negatives. We could say we have 2 negative tiles. So you could say 1x plus negative 2, or as we'll learn later on that we want to simplify this as just x minus 2. Get rid of the plus and negative and make it minus. So tomorrow you're going to be given questions and you're going to be asked to represent them in integer tiles. So our first example is 3x plus 2x. How do we represent that with tiles? Well, we need 3 x tiles, and it's a positive 3, so we want 3 positive x tiles. Next, we want 2 positive tiles, so we then take those 2, add them together, and we want to see if we can combine these different tiles. Since they're the same shape, we can actually add these together, and nothing cancels out, so we want to count up how many we have. We have 1, 2, 3, 4, 5, and they're all x tiles. So in this case, 3x plus 2x is 5x. 3 of something plus 2 of something is 5. Next one, 4x plus 3. We need to represent 4 x tiles and 3 actual just number, our integer tiles. So 4 x tiles, we bring them down here, all positives. And then we bring down 3 integer tiles, 3 positives of those. And we're stuck. All we can do, we really can't do anything else. We might want to say, well, let's combine these together, we can kind of match them up. But remember before we were just trying to match up different, the same shapes. So the actual answer to this is the question. It's just 4x and 3. We can't add those together. We do have 7 shapes, but they're different shapes. So we have to keep them separate in our answer. 4x's plus 3. Just a few more. Give it a try here. We have 2 plus 3 minus 2x. And we're going to actually rewrite this with addition. Just like we learned, instead of 5 take away 4, we made it 5 plus negative 4. We're going to do the same thing here. We're going to leave this as 2 plus 3, and then plus negative 2x. So now we're actually adding everything in. So we can add in 2 integer tiles, 3 integer tiles, and then 2 negative x tiles. So that's the red ones. And looking at this, can you look at this visual and see what the final answer is? When we combine these guys, we have 5 just regular tiles, and then 2 negative x tiles. And there is a reason I put the x first, and we'll talk about that a little bit more tomorrow too. So negative 2x plus 5. And really 5 minus 2x, or 5 plus negative 2x, it's going to be the same thing. Go ahead and try this one here. 4x minus 3 minus 2x. Let's first do this as addition. And then we'll represent everything we have. 4 x's, 3 negatives, and then 2 negative x's. Actually, I'm going to put these right here with these. So now we know that we're going to cancel these guys out because they are the same color. Those are 0 pairs there. And if you look and see what we have left over, we have 2 green tiles, which are positives, and then 3 red tiles, which remember are negatives. So this one's 2x plus negative 3, or just 2x minus 3. So there's a lot more that we'll look at tomorrow and things like that, especially with the x squareds. But this is just a couple examples to look through. Remember, I want you to look for homework. Answer this question for me. What are 2 or more rules for how I combine the shapes that you learned in this video? So what were the rules? How did I actually combine these different shapes? Write 2 or more rules down, and we will see you tomorrow. Thanks, guys.